Hi everyone, thanks for joining today. We will begin with the webinar in just 1 minute. Okay, I'll get going here. Thanks for joining everybody. Today's webinar from the weekly webinar series from Ozen Engineering is Two-Way Electrothermal Workflow in ANSYS Electronic Desktop. My name is Chris Cowan. I'm going to briefly introduce my company, Ozen Engineering, to you, and after that, Stephen Liu is going to continue with the actual content here. Okay, Ozen Engineering is a simulation-based company. We use finite element analysis and computational fluid dynamics to solve multidisciplinary engineering problems, including high-frequency and low-frequency electromagnetics, motors, signal integrity, antenna design, things like that. So, Ozen Engineering is certified as an ANSYS Elite Channel Partner, and I'm proud to say that we have been selected as the Channel Partner of the Year in the most recent year for the North and South America regions. As a channel partner, we sell ANSYS software. We provide training so that users of the software can gain expertise. We provide technical support to our customers, and we perform engineering consulting services. If anybody has a project that you don't have time or resources or expertise to complete, we will be happy to speak with you about that and give you a quote for it. Ozen Engineering works with the full ANSYS product suite, including structures, fluids, electronics, optics, and everything in between, and coupling. We also offer a couple different varieties of cloud service, including Ozen Cloud and ANSYS Cloud. If you're interested in a free trial of those, let us know. We do webinars on a weekly and sometimes bi-weekly basis. You can see on the left side here, today's topic is August 7th, two-way electrothermal. You can see on above that previous topics that we've presented, and on the right side, other topics that we've completed recently. These are all available to view on our website at ozeninc.com/webinar library. You can find it on our homepage, ozeninc.com, under resources. If you want to receive updates about our future webinars, please subscribe to our newsletter. You can do that through the website. You can register at ozeninc.com/training. As I mentioned, ANSYS Cloud is a new capability that's really bringing the software into the next generation of usage. This offers on-demand high-performance compute directly from your ANSYS flagship products. So current applications that are supported are ANSYS Mechanical, FLUENT, and electronics products, HFSS and Maxwell. These offer post-processing online through the cloud, so if you prefer, you can avoid downloading large result files. It's integrated within ANSYS, which offers single-click burst to the cloud, and it's optimized. It works well. It always works with your ANSYS products because it's integrated tightly with ANSYS software. Okay, so this is our contact info. We'll be happy to speak with you about any topic ANSYS or engineering otherwise. You can reach us at info@ozeninc.com. You can call us and you can find us on the web. I will note also that we're actively hiring electrical engineer and mechanical engineers. So if you have any referrals or want to send in your resume, please do that. Up next, our presenter, Stephen Liu, holds BS from UC Santa Barbara with an emphasis on signal processing and digital image processing. He's our local expert on ANSYS Electronics product suite. So with that, I'm going to turn it over to Stephen, and thanks for your attention.
Great. Thank you, Chris. Okay. Okay, so today's topic is integrated with electrothermal workflow in ANSYS Electronics desktop. Just a brief overview of today's content. We'll go through an introduction and overview to illustrate the thermal issues nowadays in the industry, and kind of go through the two-way electrothermal workflow in AEDT. And there's going to be an appendix giving you some information about how to installing this ACT. So the need for electrothermal analysis nowadays. So there's a lot of failure nowadays in electronics that can occur through multiple physical mechanisms. Almost all of them these failure mechanisms are enhanced at higher temperatures. It occurs in different areas, on different components. Sometimes it occurs in oxide breakdowns in FETs or MOSFETs. Sometimes there's an issue with the current leakage, and sometimes it's degradation in electrical performance due to changing properties such as resistivity, loss tangent. Electromigration might also be one of the thermal issue. Stress due to TCE mismatch, and as well as corrosion. So we can see in this chart the temperature holds a big share of the pie chart, meaning that thermal issue is really prevalent nowadays over vibration, humidity, and dust. So here is kind of like a general industrial workflow of the simulation. So what do we need for electrothermal analysis? We start off at the top with the geometry, materials, and the thermal flow environment. Given these conditions, we have a thermal analysis based on whether the device is based on the criteria to tell whether the device is at safe temperature. If it's a no, we do a design heat transfer pathways and do the thermal analysis one more time, or we can conclude that the thermal safe design for current heat load and the environment. On the parallel side, we can do a power map, or we can do a temperature map to pass it to electromagnetic analysis, or do a power map to get a power map from electromagnetic analysis to the thermal analysis. So this loop will loop until power and the temperature maps converge. So once those are converged, we can this electromagnetic with thermal analysis map will end. So the existing, not existing, the previous two-way electrothermal workflow in ANSYS back in not long ago, about 19.1. So it was still performed in ANSYS Workbench using the feedback iterator. So this workflow, it is very smooth, it is powerful, but there is a little bit setback to this. One of that is this workflow involves multiple GUIs. So you will require to open Workbench, and then you'll possibly open electromagnetic tools, which is either one of HFSS, Maxwell, Q3D, and then you will have to open ISPAC to do the thermal, or even SpaceClean to do some CAD modification. So the model had to be passed onto different teams. With this traditional workflow, the model has to pass to different teams. It has to pass through the electromagnetic teams, the thermal team, to ensure each tool had the appropriate settings for their respective physics. So during this data transfer, there's a lot of aspects engineers needs to take care of, from inputs, boundary conditions, mesh self settings. Sometimes uh, sometimes a model works in one environment doesn't necessarily mean it will work successfully in another one. So that's one of the setbacks, just too many GUIs. So so prior to R191, which is about a year ago, it was the first full release of IcePack in AEDT. So um, before that, IcePack, our electronics cooling tool, is a standalone tool that's dealing with the electronics cooling, but it really falls into the a CFD category. So back then, before R191, it was a standalone. Starting on R191, the first full release of IcePack in ADT is there, and it was only a one-way electromagnetic loss coupling. Um, so then we go to our version R19.2, which is about the same time last year. R19.1 was earlier last year. So R19.2, we have updated the EM to IcePack ACT. It becomes a multiple EM loss. It can handle multiple EM loss sources, and but it was still a one-way EM loss coupling. So now we enter this year, 2019 R1. So we have updated that to a two-way EM loss coupling, and as well as we can have a DCIR coupling with the HFSS 3D layout. Um, so just to touch a little bit on this 3D layout, HFSS 3D layout is also part of HFSS, our high frequency structure simulator. Um, that's the acronym for HFSS. That's a industry gold standard software for high frequency electromagnetic analysis. The 3D layout is just using the same solver in the same GUI, but with a different interface that's more friendly to electrical engineers. Because as opposed to um, a structure tree where the traditional CAD or mechanical engineers are familiar with, the 3D layout version opens up a different interface that takes the ECAD instead. So um, the the structures, the models are presented in layers by layers, in vias, in trace languages. So that's more friendly to electrical engineers. Okay, so after the brief review of this ACT history, we um, so starting at 2019 R1, which is the latest release, the two-way electrothermal workflow is now available in AEDT. So it is also valid for HFSS, Maxwell, and the Q3D designs. So those three, HFSS is high frequency simulator, Maxwell is low frequency power conversion, power transfer, kind of those sort of applications. Q3D is for parasitic value, parasitic parameters, and components level, uh, mainly for bus bars, transistors, and those kind of bus bars, cables, touch screens, those kind of applications. So now all these three products are in AEDT already. So with this new and with IcePack being moved into AEDT at the same time, now a two-way electrothermal workflow is available for these three with IcePack. So, well, the fundamental idea is that they will utilize this thermal modifier for materials and temperature feedback in EM designs. So in those products, when you set material information to your models, you will have the option to turn on the thermal modifier to make the material to make the structure material thermal dependent. So there's two approaches to this two-way electrothermal workflow. We can either use the electrothermal ACT, which is what I've been introducing all along. That will be a little bit more automatic, as opposed to there's also a manual process. So the electrothermal ACT is ideal for mainly electrical engineers, as well as mechanical engineers, to analyze some critical components independently and in an automated way. Most importantly, automated way. So iSpec model only includes the components analyzed in the EM design. It's only available for generic natural convection and forced convection scenarios. Where the manual process, it is mainly ideal for mechanical engineers trying to analyze detailed system level models. In that way, iSpec model can include several other components. So it will be chassis, fans, heat sinks, and etc. In addition to the objects and analyzed in EM design. So, and also any custom scenario can be analyzed. So manual process has more flexibility as opposed to the ACT approach. So for the ACT workflow, there's basically 4 steps. We complete the EM analysis in the electromagnetic tool. Then we launch the electrothermal ACT in AEDT. Then we specify the simulation type, mesh and solve settings, and two-way coupling criteria. Then lastly, we simply click launch to run ACT. So this electrothermal ACT, some key features. So the objective of this ACT is that it will automatically run an electrothermal simulation using the AEDT iSpec. So a couple key features. It starts from an existing HFSS Maxwell Q3D designs, and the toolkit automatically completes thermal simulation using AEDT version iSpec. The geometry and the material information will be copied over from the EM tool to iSpec. The EM losses will be mapped automatically from EM design to iSpec. Boundary conditions for the thermal setup are automatically created depending on the choice of natural or forced convection. Mesh and the solver settings are set for the iSpec design if those options are enabled. The two-way coupling criteria can be defined for automatic workflow. So those are some key features. Just quickly take a look at a couple scenarios. So first scenario, we have a forced convection, which is active cooling. So the inputs are flow speed, flow direction, and ambient temperature. Computational domain is as follows. So it will have a box around the geometry, the padding. It's based on the largest length in the geometry. So I believe the two ends are touching. 100% padding added upstream and downstream of the model in the flow direction. So as we can see, the inlet boundary condition is here at this wall. The outlet boundary condition is at the lower bound of the wall. We have the EM losses. So as it was said, 100% padding added to the upstream. So that's why the box is rectangular as opposed to square, I guess. So 25% of the padding is added perpendicular to the flow direction. So the two ends of this structure was not touching the boundary conditions after all. Solving settings is the sequential solver is used and the radiation is turned off. So really, after you have this model simulated in the EM tool, you can open up the ACT It will be just a little window or pop-up window on the right side of your AEDT GUI, and you select the type, you specify these three inputs, and bang, you can launch it. So that'll be our first scenario. The second scenario has even less settings to play around. That's natural convection, which is passive cooling. We only have two inputs here, which is gravity, direction, and ambient temperature. We only need to specify the type, the gravity direction, which is -z, as well as the ambient temperature as 20 degrees Celsius. Computational domain is, in this case, we have to specify 200% padding in the direction opposite to the gravity, 100% padding added to the direction, 100% to the direction of the gravity, 50% around perpendicular to the direction of the gravity. So nice and simple. Everything is ready at this moment, so all we need to do is click launch in the ACT. So a quick overview of the entire ACT GUI and the options that we may have. Project designs, we launched ACT. Launching the ACT will populate a list of projects, designs, and setups for selection. Up to 5 designs can be selected for coupling to iSpec. So you can run up to 5 designs simultaneously using this ACT. So as in the picture now, we can see it's set it to 2. Number of EM designs is set to 2. So we'll ask you the project name. Under the project, there will be 2 designs. That's where the 2 came from. If you have up to 5 designs under one project, you're more than welcome to submit the job as 5. Simulation type, as we discussed before, there's only forced or natural convection options available. Based on different selections, you will have different inputs to play with. And then we'll have a mash and solve option. So the mash and solve settings, we have 3 options. It's either mash and solve, so that the geometry is copied, EM losses are imported, iSpec model is set up based on user inputs, and it will mash and solve it. Basic post-processing is also displayed. Then we have the mesh only option, which will automatically end after the mesh is generated. Solving the post-processing have to be completed manually in this case. The no option would be automation ends after thermal analysis has been set in iSpec. Mashing solving the post-processing will be completed manually, useful when advanced mesh is needed. We'll also have a 2-way coupling options down there at the bottom of the ACT. Couple options would be 2-way coupling to EM design. Selecting yes enables bidirectional coupling of EM design and iSpec. Number of coupling iterations will define the number of times EM design and iSpec simulation must be launched and updated with new results. Whether continue iSpec iterations doing coupling, if iSpec will use the previous solved solution as the initial condition for each subsequent loop. This results in faster convergence. And lastly, we have launch button and the finish to quit the ACT. So some other important points. This toolkit to be notified is that does not support 3D components from the EM design. This is something ANSYS is still working on, but I guess it's still not implemented yet. So we also had another webinar a couple weeks before talking about the 3D components. It is also a very powerful feature in the AEDT where you can save a component analysis, save an analysis for a certain component that you want to use uh, time over time, and it also has the capability uh, to make an encrypted model so that you can pass it to a customer, or your vendor can confidently pass it to you. For more information, you're welcome to explore our webinar library. Okay, so this toolkit does not support 3D component. Good to know. For material assignment from the EM design, it must include the thermal properties. So the thermal modifier has to be turned on. The toolkit uses ISPAC slider bar matching, for example, for complex geometries. No option should be used for match solve to manually match the model. Also, for the two-way coupling, make sure the EM design is set up appropriately. Meaning that temperature-dependent material properties are set and enable feedback is checked in the EM design. So just same as before, like we want to make sure the materials are temperature dependent so we can do a thermal analysis. For the HFSS layout, only one-way coupling is available. The toolkit will automatically create the mesh regions and assign appropriate mesh settings. So this is probably referred to the 3D layout interface that I mentioned earlier, because it's a different solving or meshing technique in the 3D layout, because it will treat the boards and the layers in a 2.5D way so that it solves faster, meaning that when it comes to coupling, sometimes when it comes to coupling, the two-way is not available yet. So we'll be talking about this ACT for quite a while. It is available to download it from ANSYS App Store. The link is right here, and it is free. Ignore this little star here. This might be obsolete. It should be available now for 2019 R1, even R2, I believe. So the second approach for this two-way electrothermal would be a manual approach. So it requires one more step than the ACT. So as the same as the ACT workflow, we complete the EM analysis in the EM tool. Instead of launching the ACT in this workflow, we insert a new ISPEC design and copy paste the geometry from the EM design. We might need to add some additional components in the ISPEC as well. Then we select the EM design objects and import EM losses using assign thermal EM loss. Then we specify the inputs, boundary conditions, and all those conditions in ISPEC. Lastly, we add a solution setup in ISPEC and select add two-way coupling, and then we can hit analyze afterwards. So not much, not many things, not very more complicated than the ACT workflow, but it gives you a little bit more flexibility. Let's take a look at an example. It is a copper coil with some insulation and attached to a copper plate. Induction heating application at 50 kilohertz. Stranded coil above copper plates has induced eddy current losses, and insulation material between there's insulation material between the coil and the plate. So after the first coupling iteration, we can see that maximum temperature is about 103 degrees Celsius. Total energy is 3.89 watts. After the final coupling iteration, which is 3 passes later, we can see that it converges better. The maximum temperature and the total energy has converged to a different number. So we also have, ANSYS also have some YouTube videos available for different topics. For this topic, luckily we have a reference as well. Feel free to visit the YouTube channel for search EM ISPAC ACT. So just lastly, let's summarize what we have go through today. What we're trying to say today is just that this two-way electrothermal workflow is now available for sharing AEDT. It is available for these three EM tools with HFSS, Maxwell, and the Q3D. So multiple EM designs are supported for two-way electrothermal workflow. So as we saw for the ACT, we can select multiple designs to analyze at the same time. It probably doesn't solve at the same time, but you can ask them to solve by just having a single click, and they're solved sequentially. Coupling can be performed via the ACT way or the manual process. Temperature-dependent material properties and the enable feedback options has to be turned on. Objects copied over from the EM design cannot be translated or rotated in ISPAC as the losses are spatially mapped. So that's one thing we didn't explicitly mention in the previous slides, but good to keep in mind. It's that you can't do any sort of CAD operations after the EM designs has been done. If you want to do a thermal analysis, use the ACT only for the version it was downloaded. So just pay attention to the version. At this point, I believe 2019 R2 is available also. So ignore the last point. So there isn't much to demo for today's lecture. Just the appendix of how to install an ACT. So once we go to the ACT store, we can download the ACT. It will be downloaded as a .workbench extension file, .wbex. So after you have this file ready, you go to the ACT extension window. Then you go to View ACT Extensions, Manage Extensions. Then you add this downloaded executable files or extension files. Then we'll add it to your ACT console, and then you can right-click. You can click on this down arrow. You can either load it or load as default. If you load as default, every time you open the software, it will be loaded at the same time. So then you can click Launch Wizards, and then this ACT will be there for you to use. So this is all I have for today for you. If you have any questions, or feel free. Oh, there is a question. Someone said my audio was cut out. I didn't pay attention to it. It was... You can still hear me all right, right? It was 20 minutes ago. Okay. Okay. Yeah, thank you, Dave. So, any idea when the 2019 R2 ACT will be available? I believe it is available. I was using it on my own. Let me double check real quick. It should be available. We can take a quick look here. Support 19.2 v3. Okay, so the latest one is R1. Not sure about R2 release date, but you're feel free to try it on R2 because I have no problem loading it. As far as reusing it, not anything that I experienced, because usually the release are not much of a big difference, so it might be compatible, but just I guess keeping an eye on the ACT stores if you're or shoot me an email if this version doesn't work for R2. Feel free to let me know as well. Okay. So the conclusion is we are at electrothermal ACT version 3 right now, supporting our 2019 R1. Okay. Any more questions? Feel free. Okay. So if everybody is all set, thank you for your attention today. Feel free to shoot us email, give us phone calls for more information on software, on any consulting projects, or any webinars you're interested. Ozen Engineering, welcome and thanks. Appreciate your business. All right. Thank you. Have a nice day.